Welcome everyone to February's Belfast Go meetup. We've got two fantastic talks lined up this evening. And first things first is really just as usual, just mention the sponsors again, or at least put a picture up of them there. We've got JetBrains and Teamwork and Cloud Shuttle and myself at Vistas as well. So thanks to all those for making this possible. So we have two talks. The first one will be from Matthew Titmus. Matthew's talking from New York, I believe, this evening or this afternoon for Matthew. Matthew's a lead SRE at Flatiron Health, and he's going to give us a talk on OpenTelemetry with Go. And Matthew's also funny. Both speakers tonight are authors in waiting, have books on the way or on the go. Matthew has a book coming out in May, I think. Is that right, Matthew? Called Cloud Native Go, which all intents and purposes will be quite a good read. And I'll tell you more about Ellie when we tend to introduce her. So first up we have Matthew. Matthew, you can go ahead and share your screen, and here's Matthew telling us about OpenTelemetry with Go. Away you go, Matthew.
Excellent. Thank you very much. As soon as you're done sharing, I'll take over. There we go. And I will share. Let's see. I think I'll start by sharing. Is that what I want to share? Am I sharing the correct thing? I think I am.
Yeah, we see your slides now.
Wonderful. So yes, thank you everybody for having me. It's really nice to be here. I'll have to confess there's a little bit of a mad dash to finish things up with the quality that I was hoping to express in this slide deck. So I hope there aren't too many problems. First, I would also like to say that if you have any questions or just want to talk to me, that's okay too. Please feel free to interrupt. I have a general talk policy that if you have a question, other people probably do too, and I'd rather deal with it while people are thinking about it. So feel free to just jump in anytime. That's fine. So without further ado, let us move forward. So first, hi, I'm Matt. I have I've done some things. I am an SRE tech lead at Flatiron Health. We're based out of New York. I'm in the middle of a blizzard right now, so my internet may be spotty. Please tell me if I need to repeat anything. I've been in the industry for a little while, since Java was cool, which is a long time. I'm an academic refugee. I learned some things about molecular biology and cancer biology and stuff like that. Turned out I was terrible at research, but I was okay with computers. So I'm doing that now. Organized for a DevOpsDays Conference in New York. I founded the CoffeeOps meetup out of New York, and I'm in the author of the buzzword compliant cloud native Go, which is coming this May. Please buy my book. It makes me feel like people like me, and I like that. So first, I'm going to jump in. I can't really see anybody. Can you either raise hands or use the raise hands button if it's possible? What is your expertise level with Go? Would you consider yourself advanced? If people don't want to show themselves, that's okay too. You know, we can skip over this whole part because we've got some interesting stuff going on back there. So, all right. So I'm going to target this mainly as middle of the road, largely as an exploration of not just OpenTelemetry, but observability in general, why it exists, and assuming that most people aren't familiar with OpenTelemetry, because I had to do an awful lot of digging to figure out kind of what was going on with it. So hoping to share that. So, all right. Before we move on, well, let's dispense with the questions for now. So, observability. Now, a lot of us have probably figured out by now that in the tech world, the network and hardware layers are being increasingly abstracted. They're being replaced essentially with API calls and events and all sorts of fun stuff like that, which puts us into something of a brave new software-defined, highly distributed, kind of ephemeral world that solves a number of problems. It lets us focus on our software, which is pretty neat. The abstraction allows some measure of consistency, at least more than we used to have. It facilitates automation and auto remediation, which I'm particularly fond of as an SRE. And it lets us orchestrate huge fleets of services, which again is really, really neat, but it also introduces some new problems. But most of our failures are now originating from this software-defined world, from within our own services and in the interactions between them, which puts us in an odd place because between that and the scale that we're working with and the complexity that we're working with, it's hard enough to find out what a failure is, or what the nature of a failure is within your system. But how do you figure out, where it is when you have this complex system full of this complex web of interacting, sometimes ephemeral services? And things are getting complicated. The software is complicated, the platforms are complicated, together they're really complicated, and more often than not, we have no idea what's going on. And getting some visibility into our services and resources and what they're doing has become more important than ever. Really about the only thing we do know at this point is that traditional monitoring tools, whatever that means, and techniques really just aren't quite up to the task. They don't quite do what we need them to do. Oh, I forgot to put a title on that. Oh well. So at one point, and maybe I'm dating myself at this point by talking about this, at one point I remember when systems were simple enough, even the enterprise ones were simple enough that it was possible to understand most of the failure modes of a system. You could predict them. You could look at a design and say that could fail. That could be a thing. We'll have to watch that thing. So this traditional monitoring focused around looking at known unknowns. It was generally good enough. So a thing would fail, or you'd predict that it was going to fail. You'd build a monitor around that thing, be it like your queue depth or disk I/O, whatever. You'd build an alert for that thing, and sometimes you'd build a dashboard and to show the thing. You might put it up on a wall and it make you feel smart. And it was really pretty, awesome. Then something else would fail, and then you just build an alert for that. And generally, you could count on the same kinds of things failing more or less consistently. But systems don't work the way they used to. They definitely don't fail the way they used to. It's just not possible anymore to predict all the possible failure modes. At a certain level of complexity, the unknown unknowns start to overwhelm the number of known unknowns. And sort of as a consequence of that, system failures are more and more frequently entirely unpredicted. They're less and less often even predictable. And they're nearly always the product of many things going wrong. Cascade failures are fun, let's just say. And importantly, a particular failure, a particular type of failure, a particular failure mode, a particular pattern cannot be relied upon to happen again in exactly the same way. You don't always know exactly what to look for. May never happen again. So what then is the solution for this? Well, there's no solution for it, but that encourages a different way of looking at these things, a different way of looking at monitoring, a different way of looking at the systems in a way that we can we'll get to that. But essentially what that forces us to do is to build in a level of observability into our systems themselves. We are no longer in a place where we can monitor as a verb to a noun the system. We now are at a place where we have to be able to ask the system questions, sometimes arbitrary questions, sometimes questions we hadn't thought of before. So where that leads us to is a system property, observability, that a system has, which describes some scalar quantity that describes how well we can extract the state of a system from its outputs. Now, observability has become something of a buzzword. It's not hype, I promise. It definitely doesn't really have all that much to do with tooling, whatever they try to tell you or sell you or whatever. You cannot buy observability. No vendor is going to be able to just parachute in and give you observable systems. It's just a property. The definition, the formal definition, if you want to be formal, a system is observable when it's possible to quickly and consistently ask novel questions about it with minimal prior knowledge and without having to re-instrument or build new code. All right, I don't do formality, really. So I like this better. I think this comes by way of charity majors, I think, is where I got this. Observability lets you ask questions that you haven't thought of yet. You're talking about high dimensionality, high cardinality data that you can construct arbitrary queries in some way and get the information you need to do exploratory analysis on your system. Fine, cool. Now, how do we get there? All right, this isn't how we get there, but it's important. It's a first step. The so-called 3 pillars of observability. I hate this term. I hate it so much. It makes it sound as though like this is like how you do observability, is like you plug in these 3 things. It's totally not that, but these are useful tools that you can use to increase your system's level of observability. Okay. Logging, the process of appending records of noteworthy events to some immutable record. I said record twice. The log for later review or analysis. We won't talk about this, but I will say the best logs are structured logs, but that's all I'll say for now. Metrics, I won't have time to get into that, I don't think either, but that is, it's also a very interesting thing. Collection of numerical data points, you're all familiar, that represent the state of various aspects of the system. Really good for visualization, mathematical analysis. You can do transformations to highlight trends or identify anomalies or predict future behavior. Very, very useful, very, very cool. Tracing, which is where I'm going to spend the bulk of my time. Tracing with OpenTelemetry. That's the most mature aspect of OpenTelemetry. Tracing allows you to associate causally related events and sub-events and sub-sub-sub-events and so on that occur as a request propagates throughout a system. Typically a distributed system, but it doesn't have to be. You can do tracing on a monolith if you want to. You can, wrap all of your I/O and requests out to databases in spans if you want to. We'll get there. This allows the entire end-to-end request flow to be reconstructed as a DAG called a trace. It can provide insight into how a system's components interact. And it makes it easier, which is most relevant for, I guess, our purposes today, to pinpoint failures and performance issues. You can see by looking at a trace where the request is falling off or where the spans are spending all their time. It makes it pretty clear where your bottlenecks are, where your issues are. What's important to know, though, is that each of these so-called 3 pillars of observability provides a different view of the same thing. If these systems are well understood and used well together, they can provide pretty deep insight into the internal state of your system, and ultimately enhance your ability to understand the state of the system. Anyway, this isn't meant to be a missive on observability. There are plenty of those already. Just keep in mind that observability is a property. A system is or isn't observable. Observability isn't just the tools that you use. Is there any way we can take questions without being afraid? If we have any?
Any questions there?
Before I continue.
Normally we use the chat, but I'm not sure if we can use the chat right now.
Yeah, it's all right. So we'll just roll on. I haven't said anything really important yet, and I doubt I will. So, cool. OpenTelemetry, the fun part. As of the time of this writing, OpenTelemetry or OTel, because the cool kids are calling it OTel, and I'm totally not one of the cool kids, so I won't call it that. It's one of 4 dozen, like 50-ish sandbox member projects of the Cloud Native Computing Foundation. I think it's one of the most interesting projects in the entire project catalog of the CNCF. But unlike most of the CNCF projects, it's not a service or a platform like Kubernetes or Prometheus or any of those other fun things, but it's a standardization effort primarily. It's an effort to standardize how telemetry data, in particular traces, also metrics and eventually logs, are expressed, how they're collected, and how they're transferred. So now there have been other attempts to standardize these things before, several. In fact, OpenTelemetry is the merger of 2 such projects that came before it. Is Open Tracing and Open Census, both focused largely on tracing. I think Open Census also included metrics. Neither of them cared at all about logging because just logging. And if you look at the OpenTelemetry source code today, there's still a fair amount of carryover from these earlier projects, and a fair amount of effort being made to hammer them into a consistent shape. Some really interesting stuff is in that API if you ever get a chance to dig into it. So this this project includes specifications along with some SDKs, reference implementations in various languages. Go is the one I care about. The other ones exist. That's all I've never used any of the other ones. OpenTelemetry in general is quite new, but it has had some really impressive progress in terms of its development and some really impressive adoption, even now at this fairly early stage. It's not GA yet. It's been in beta since almost a year. It has significant support in the community, about 100 or so private and corporate contributors to the OpenTelemetry specification alone. Many open source products and frameworks integrate natively with OpenTelemetry. MySQL, Redis, Kafka, Postgres, Flask and Spring, if you hear about those, Postgres, and even the Go net HTTP framework, whatever it is, package, and Gorilla Mux, both work really nicely with OpenTelemetry. I'll show you some short examples of that in a bit. Also, major commercial providers have thrown their weight behind it, like Honeycomb, Datadog, Splunk, New Relic. The primary downside to OpenTelemetry right now is its newness. Again, it's still in beta, proceeding to GA, release candidates even. Support for logging hasn't even started yet. So as of now, there aren't even any comprehensive resources available about OpenTelemetry, although Charity Majors and Liz Fogg-Jones are working on a book right now about observability that will feature centrally OpenTelemetry, and I'm really excited about that. But I have been able to gather what I can from examples and a handful of articles and an awful lot of digging through the source code. I hope that you find it useful as well. So let us start actually talking about OpenTelemetry. The entirety of OpenTelemetry is structured in a way to maximize its ability to support abstractions. Extractions and extension points in the SDK where you can insert your own implementations. It makes it possible to implement custom supporters that can interface with a lot of vendors of your choice. That is important. I'll explain that at the end of the slide. The core components are, of course, the specifications itself. Of course, the API, the language-specific interfaces and implementations based upon the specifications. They can be used to, instrument your code. The SDK, which is concrete implementations that sit between the API and the exporters themselves, provide functionality like state tracking or batching your data for transmission. There's also a bunch of configuration options for behaviors like request filtering, transition, like sampling, stuff like that. Very, very useful. The exporters themselves are in-process plugins that all know how to send data to a specific destination. These can be local, like a log file or standard out, which is great for debugging, or remote, so like a Jaeger service or a commercial solution like Honeycomb or Lightstep or something like that. These are really nice because they decouple the instrumentation from the back end. They make it possible to change destinations without having to re-instrument all your code. If you've ever had to migrate from like Datadog to something else like SignalFX or something like that, you had to rip out a bunch of custom code and replace it. That's just gnarly, and I don't wish it on anybody. The collector, I also want to mention the collector briefly. The collector is actually, it's totally optional, but it's really, really useful. For the most part, at least initially, all of your code, the exporters in your code will send telemetry directly to its target. But a collector is it's a service, vendor neutral service. You can configure it the same way you do a lot of other things. All the same exporters are usable with your collectors as with your actual code. But it's a service that can run and receive process telemetry and then forward it on to your telemetry backend, which can be useful as a sidecar process, which means you can focus your configuration options on your collector, if you so choose, and let your code just send everything to the collector. It could be run as a sidecar process or a standalone proxy, which is great for flexibility. And it's actually really, really handy if you're working in a tightly controlled environment. If you have to worry about compliance and stuff like that, it's really common in the enterprise. I work in health tech, so it's particularly useful in environments like that. Telemetry backend, there isn't one. There isn't one in OpenTelemetry, and that's on purpose. OpenTelemetry is only concerned with the collection, processing, and sending of telemetry data to the backend of your choice. That backend, again, can be for metrics, can be Prometheus, for logging, it can be Splunk whenever logging is done. For tracing, you have your Lightstep, your Honeycomb, your Jaeger, et cetera, et cetera, et cetera. Here's just a short list of the vendor neutral some of the vendor neutral exporters. Again, no external setup really. There's a Jaeger exporter, Prometheus exporter, standard out exporter. There's a bunch of other ones too. I'm not going to read this because I don't feel like it. I want to look at code. Before we move on, does anybody have any questions?
Guys, I hear shots.
I beg your pardon?
Feel free to unmute if anyone has a question.
Cool. So I know these remote talks are interesting. I mean, I have no idea if I'm
Okay,
going
so
to...
maybe I'll have a question. What is the
Sure.
difference between, like, from your perspective, between open tracing, OpenTelemetry?
I haven't used open tracing an awful lot, to be honest with you. So I can't really speak in a competent way about open tracing. OpenTelemetry, I mean, I can speak somewhat about that, but it's difficult for me to compare and contrast, I'm afraid. I don't want to embarrass myself any more than I already am.
Okay, thanks.
Sorry.
No, it's okay.
Cool. So, all right, then. Tracing. Tracing is the only aspect of the so-called 3 pillars that I'm really going to cover because it's the most interesting. We only have so much time. Some quick definitions. A trace, the tracing thing, is composed of 2 components. There's the span, which is a unit of work. I'll show a picture after this, so these will sink in. But a unit of work performed by a request as it propagates through a system. So that could be a fork in the execution flow or hop at the network, something like that. So it's 1 unit of work. So here's a call to this particular service. Here is a database query, and that is performed as one thing that looks atomic. Almost certainly isn't, but anyway. Every span has a name, has a start time and a duration. So you can see how long the span took. And multiple spans can be, and typically are, nested in order to model causal relationships. So you have span A, and then span B might be here. Oh, I'll get to the picture in a second. A trace is a collection of spans. So it represents all the spans that make up a single request as it flows through the system. You can think of it as a DAG, directed acyclic graph of spans. It's kind of like a stack trace, kind of, in which each span represents work done by one component. Visually represented, looks sort of like this. So I have 2 representations here of a trace of a request as it traverses 5 services, resulting in 5 spans. 1 trace. The full traces are represented as, do I have, let's see. Hang on one sec. Cool. Oh, I have, can you see the tracer now, the pointer? Excellent. So we have, so here, so single trace A is represented over here. So each of these represent the same thing in 2 different ways. We might have the parent span here that takes about 350 milliseconds. It does a thing that is done here. This does a thing and then another thing, which you can see here, and they're represented there. And then once again, once B is done, E is taken, is another thing, and that gets done, and then that ends, and then you have this span here. So each span, again, has a name, a start, an end. It also has parents. So this has, and this have the same parent. This has, this is a parent, so on and so forth. Did I rush that? Is that okay? I'll say it's okay. So awesome, thank you. In OpenTelemetry, to execute this in OpenTelemetry, there's some steps we go through. We have to do an initial setup and then the actual instrumentation. The initial setup is pretty straightforward. It becomes muscle memory after a while. You have to create your exporters. Your exporters can be, I'll show an example of the standard out exporter, console exporter rather, and the Jaeger exporter. Those exporters are then used to create a tracer provider. The tracer provider is the main entry point for OpenTelemetry, for the OpenTelemetry tracing API for the lifetime of your program. You can set that. That gets stored in memory somewhere. There's a global tracer provider. You don't have to store it. The API takes care of that, and you can retrieve it at will. The global tracer provider, as you're saying, once you've created the tracer provider, you assign it as the global tracer provider, and then becomes discoverable by the OTel.getTracerProvider function. This is convenient for you, sure, but also allows other libraries that you may be making use of that are instrumented with OpenTelemetry to also discover your traces, your tracer provider rather, and extend traces appropriately, which can be really, really handy. Once you've performed your setup, your instrumentation is 3 steps, well, 2 and an optional one. You get your tracer from the tracer provider. That's the first thing you have to do. This is a required step. Grab it usually from the global tracer provider. This has the role of keeping track of the trace and span information. So it has state. You then start your new span. You can use a tracer to create and start the span. And that's the actual value. You get a span value back that you operate on to instrument your code. This has some methods to it. I'll show those in a sec, but let's do start, stop, and then add metadata to your span. This includes not just the time span, but you can add key value pairs called attributes, or you can even add time-stamped human readable events. They're logs. They're logs. So code, the fun part. So what we're showing here is the creation of 2 tracing exporters. We have, let me just hang on a sec. Real straightforward. You want to create your console, your standard out exporter. You can do that. You just standard out.new exporter. Super simple. There are multiple options that come along with all of the instantiation functions, the new functions for these. They're all variadic. They can take whatever you throw at them. The console exporter takes only a couple, but in this case, you want a pretty print. It'll print everything out in JSON. Typically, if you're a human like I am, and I'm sure most of you are, it's most readable if you pretty print it. Jaeger exporter takes a couple of arguments. In this case, we're going to send it to a Docker container that's running Jaeger, and the endpoint lives here. I'm going to call it Fibonacci because that's what I'm going to use to actually demonstrate the thing. And that takes a few more things. So you have to, your exporter, you pass it your collector event. I'm sorry, your collector endpoint, and then the process setup. In this case, just the name, just to be straightforward and very, very simple. Okay, so once you have your exporters, in order to generate traces, you have to create and initialize the tracer provider, represented by the tracer provider type, which we have here. So you just take our 2 exporters and we pass it to the tracer provider. Done and done. Pretty straightforward. Now that we have the tracer provider, we can pass it, call it the set tracer provider to define it as our global. And now whenever we want to create a named tracer, create a named tracer, we can just get the tracer provider, which returns our tracer provider, as you might imagine, .tracer, and then just give it a name. And we have our tracer, which is pretty straightforward. Some functions that come along with the tracer. Again, like I mentioned before, there's a start function where you actually start the trace. There is a with span, which will start a new span, set it to be active. I'll show that in a sec. And then in many cases, the span, actually I think it's just called from context now. The from context function is method is really useful if you happen to have a context, a derived context that your function method has been passed. you can retrieve the current span from that. Because fundamentally, the context is what carries all the information for your spans under the covers. Once you have it handled to your tracer, you can use it to create and stop new span values, like I had showed before. The span represents, like I mentioned, the equivalent of one step in a stack trace. Tracers method, tracer, and we have start. So many windows. So we have now OTel, get our tracer, pass it a name, call it whatever we want. This starts the root span because we're in a main, so we're starting the root span. This also will provide a context value in addition to the span itself. That is really important because it's, like I had mentioned, it's the context that retains the ID of the current span and some of the metadata. So it's really critical that you maintain that particular context. And then 0 or more configuration options. So here's the span. You start, defer the end, which will complete the span. And then you do whatever function. And then that span, of course, will be started here. At the end of the function, it'll be ended. The notice here, we have sum function, we pass it the derived context. This will allow sum function then to do something very similar, where it can also get the tracer provider, create a tracer, and establish a span. When it does that, because it's using this derived context, the span that it creates will automatically be associated with the parent span, the span above it. In this particular case, it'll be the root span, which is really nice, really clean, really under the covers. You don't have to worry about managing your spans besides just creating them and ending them and passing context around, but we're used to that. We'll go into this a little bit more, but you can add events, you can add attributes, and you can end your span, typically with a defer. Let's drill down into span metadata, key value pairs. You can, these are great for, and I'm gonna rush this a little bit because I wanna show a little more code, but these can be used later for aggregation, filtering, grouping traces. You can either create them at span creation. So in your trace.start, you'll pass it the context and dot attributes, dot with attributes. Variadic functions all over the place here. Or you can attach these events. These are attributes. These aren't events. I messed that up. But anyway, these are attributes. You can attach these attributes after the span has been started as well. So say you come up with some answer. Let me know if you get this answer. You can attach it later on as with just a set attributes method. Real straightforward. These are events. Events, which are log events, they get pinned with timestamped values on your spans. Nice, simple. For example, you could do span.add event, do your thing, do whatever, and do another thing. Not complicated, not too fancy. So the interesting bit is if you're building something like a service, you're using like Gorilla or you're using something like NetHTTP. We're all familiar with this particular idiom here, where we have our, this is a simple net HTTP service. We have our handle func with a hello go handler. It'll just do hello go or something like that. And then we will actually start our service. With auto instrumentation, we're able to take the handle function and wrap it in a function that will automatically start and stop the events. Will start and stop the spans rather. It'll be able to automatically extract the context, the span information from the context that's being associated with request. In this particular case, the only difference here is new handler, and we pass it the exact same stuff. So here we have the handle func, that stays here. So new handler and a name that we're just calling root here. And for instrumenting the web service functions themselves, that's it. That's all you really have to do. Automatically done. I don't have an example here for GRCP, but something similar exists there. I don't have time to cover that, unfortunately. But I will show you a live thing. Anybody want to see a live thing? Which is basically this.
Always.
Okay, cool. Live thing. Can you all see my screen? That is not the presentation. Am I sharing correctly?
I can see live thing.
Live. Oh, okay. I'm gonna have to reshare. Hang on. That looks like, how about that?
Yep.
Okay, cool. So here is a very simple web service that I put together that shows pretty much exactly what we did in the examples. So going down to the main function, I have here where I just create and register the exporters, which does exactly as it says on the tin. Create the standard out exporter, the console exporter, whatever you want to call it, Jaeger exporter. And then it sets up the tracer provider and then sets that to be the global. Done and done. And then it grabs the fib handler, which is our handler function. Wraps that in a handler func and then sends that to get the auto instrumented new handler OpenTelemetry function. The Fibonacci handler is a really bad implementation. Don't do this. I did it basically because it makes pretty graphs. It will grab an argument from the query string, n, and it will then, what did I do here? Oh, right, duh. Call the Fibonacci function. The Fibonacci function, this is the terrible implementation, calls itself concurrently. This is really bad. Don't do this, okay? It's not how it's supposed to really be done. Creating two Go routines that both come back and eventually are added together to set this results attribute in our trace span. There we are. And there are, of course, back in the fib handler, there's also its very own gets the span from the context, because again, we have the context, but we don't have the parent span, and that's really what we do there. I have a little script that just starts a Jaeger container. So I'll just call that now. Start Jaeger. I have that running. I'll have to share that separately. And then I will say, I think we can do, let's see, we can do, what is the, hang on one sec. I have the thing, hang on, I lost the actual port. Where did I store that? Oh, I know. I have to do this. Here we are. So I will steal this. So first, I'll do this. So that went, executed the Fibonacci function, and I'm going to change this a little bit. So I'm going to do this again, but I'm going to do it effectively not concurrently. And we'll have a whole separate, have to restart. Oh, by the way, this is the output of the console exporter. So it's very verbose because we have multiple spans here. Oh, I need to do this. So I'm going to restart. I'm going to run that again. What did I do? I broke a thing. Oh. These are channels. Told you it was terrible. Okay. And then I'm going to do this again, not concurrently. So now I'm going to stop and I'm going to share the Jaeger UI, which will put that there and share.
Yeah.
All right. So now I've done, I'm in the Jaeger UI here. Find traces. We have two. So we have the first trace and we have the root. There's 26 spans in it. We take a look at it. This is exactly what we just did. So this is the Fibonacci function. There, this is the root span. Put a bunch of tags on it. So there's a whole bunch of stuff here. And even the Fibonacci individual spans, every result and every query are attached to the span. If we take a look back at the, so again, this is the, oh, it's ugly. Come on, come back here. This is the concurrent one. Here is the, no, that's the concurrent one, sorry. Here is the not concurrent one, serial. You can see it's very different signature here. And you can tell clearly from the span what kind of format we're looking at here. So does anybody have any questions or anything they want to see here?
There's a question in the chat, Matthew.
Oh, I'm sorry, I couldn't quite see that.
That's all right. No, I just was waiting for a moment to interrupt.
Oh, of course, of course.
It's from Robert. He's asking, have you been testing any manual tracing instrumentation? He said, I looked at Hotel Go repo and saw something like test exporter, which probably is the way to go, but not use a global provider. But that's just his guess. Maybe you have some experience in that area.
I'm afraid I don't. I've mostly been consuming the hard work that the good contributors of the OpenTelemetry project have been doing. I haven't done any actual testing of it or done any testing of any kind of tracing of really any kind. So unfortunately, I can't speak to that either. I'm over 2 today. I'm sorry.
Anyone got any other questions at this stage? We've opened the chat again, so you can write in the chat.
I'll go ahead and stop for a moment. You're welcome, Robert. You can see the chat now. This is pretty much all I have. Basically, the only slide left is a thank you for listening slide. So I'll just dispense with that and wrap it up here. Does anybody have any other questions though before we call it?
Anyone? Don't be shy.
All right. Well, everybody, thank you so much.
Oh, there's one late question coming from Robert.
Yes.
Any particular stuff that you wish to know before using it?
That I wished I knew about.
Yeah.
I wish that I knew, because I had heard good things about it. I wish I knew how undercooked it still is, and it is quite undercooked. I was really hoping that I could do basically all my observability, 3 pillars things with it. There's no logging support, so I've been using Zap, which is okay. I like it more than Logos right now because it does structured logging better. But I know that's a unpopular opinion. But even the some of the idioms that are used with monitoring and the monitoring aspects of OpenTelemetry are different. The way they put together like monitor providers and stuff like that work a little bit differently. They're not as consistent as you would imagine they would be. There hasn't been a lot of effort really put into making that consistent yet. All the real work has been getting to get the tracing aspect to GA. So I expect that'll come pretty soon. But yeah, that's sort of a long-winded way of me saying that yes, I wish it was a little more mature, but still, I mean, it is still really neat.
Cool. Okay. I think that might be it on the question front, Matthew.
All right. Once again, thank
Oh, there's another one.
tracing of events could replace logs. It really depends on what you're using logs for. If you're using logs as a stream of consciousness, which I wouldn't recommend doing, no. But if your logs are intended to reflect interesting, important events, then yes, they probably could. To a large degree, the way that the data in traces and the events that are represented as events on traces and logs are pretty interconvertible. I think if you use the events on traces exclusively, that would enforce some best practices. If that makes any sense.
Mm-hmm.
Thank you, Robert.
There we go. Okay.
All right.
Thank you very much, Matthew. That was really interesting. And thanks again for taking the time to chat this all.
Of course.
And,
thank you so much. And I apologize for running a little over.
No, that's fine. We apologize for all the